Good morning, students. So today we are going to discuss about valence bond theory and types of overlapping, that how electron clouds overlap, orbitals overlap, and there is formation of different types of bonds like sigma bond and pi bond. Okay, and how many types of overlappings are there. So first of all, how we came across valence bond theory. So before valence bond theory, what we studied about the covalent bond formation. Okay, so covalent bond is formed by sharing of an electron pair between the respective atoms. Okay, but because of, if we know how covalent bonds are formed, we cannot get any idea about the shape of polyatomic molecules. Okay, similarly, then came Vesper theory. This Vesper theory told us about the geometry of molecules. Okay, but it is not applicable to all, it is having very limited applications. Then valence bond theory was given by Hitler and London in 1927, and Pauling and his co-scientists further developed it. Okay, so what is this theory? This theory is based on the knowledge of atomic orbitals, electronic configurations of elements, and overlap criteria of atomic orbitals, and hybridization of atomic orbitals, and the principles of variation and superposition. So basically, what is to be remembered, in valence bond theory we are going to talk about attractive and repulsive forces, on the basis of which we will see whether a particular molecule exists or does not exist. Okay, basically we are going to see this thing only. Now let us consider the formation of hydrogen molecule, which is the simplest of the all molecule. Okay, with hydrogen molecule we are going to discuss how the process goes on in case of valence bond theory. Now consider two hydrogen atoms A and B. Okay, they are approaching each other, and Na and Nb represent their nucleus, and electrons which are present, they are represented by Ea and Eb. Means Na is the nucleus of A atom and Ea is the electron present in that particular atom. Similarly, Eb is the electron present in B atom and Nb is the nucleus of atom. When the two atoms are at large distance from each other, there is no interaction between them. Okay, when they are at the very large distance, then there is no interaction between them. As these two atoms approach each other, but when they start coming nearer to each other, then what happens? Then two things we can see: new attractive forces will come into action and new repulsive forces will also come into action. So now as far as hydrogen atom is concerned, then what will be the attractive forces? Nucleus of one atom and its own electron, that is Na Ea and Nb Eb. These attractive forces are old attractive forces, because when A atom was there, then nucleus was also there and electron was also there. So this is old attractive force, this is also old attractive force. But when they are coming nearer to each other, then what happens? Nucleus of one atom and electron of other atom, they get attracted. So nucleus of A atom attracts electron of B atom and nucleus of B atom attracts the electron of A atom. Okay, so this is a new attractive force. Similarly, okay, let us first discuss attractive force. Now see, this diagram is for attractive force. Now here dotted line represents old attractive force and this broad line represents new attractive force. Now from this diagram, what you can see, this is old attractive force, this is old attractive force, but this is new attractive force and this is new attractive force. It means how our electron is represented, how our atom is represented. This is one atom and this is second atom. Okay, here this is the nucleus and this is the electron. Similarly, in the second atom, this is nucleus and this is electron. Okay, now they were attracting each other already when they were alone or when they were at far distance. Then they were attracting each other, and that was the old attractive force. Now when these two came near, then this force came into action and this force came into action. Nucleus of one atom started attracting the other atom. So if we see this diagram, then there are two new attractive forces. Similarly, there is repulsive forces also. There is presence of repulsive forces also. Electrons of the two atoms, they will repel each other. Similarly, nucleus of the two atoms will repel each other. So if this is one atom and this is other atom, then the nuclei will repel each other. This is one new repulsive force, and this electrons will also repel each other. This is second repulsive force. So there are two new repulsive forces. Okay, now what we have seen that there are two new attractive forces and two new repulsive forces. Now since their number is same, so on the basis of their number we cannot say whether this molecule will exist or no. So now in this case we have to compare their powers. Power of new attractive forces is more than the power of new repulsive forces. So the overall result is that this molecule exists. Okay, or in some cases when there are more attractive forces and less repulsive forces, then on the basis of number itself we can say that the molecule exists. But when the number is same, then we have to see their magnitude. Now in this case, magnitude of attractive forces is more than the magnitude of repulsive forces, so hydrogen molecule exists. Okay, now we come to orbital overlap concept. Now what is orbital overlap? Now in case of hydrogen molecule, we are talking about hydrogen molecule, there is a minimum energy state when two hydrogen atoms are so near that their atomic orbitals undergo partial interpenetration. Okay, now see covalent bond, how covalent bond is formed. Covalent bond means partial interpenetration of electron cloud of one atom with the electron cloud of other atom. Okay, now this thing is also given another name. The partial merging of atomic orbitals is called overlapping of atomic orbitals. Okay, which results in the pairing of electrons. Now pairing of electron means there is bond formation. Okay, now how much overlapping has occurred? What is the extent of overlapping? That decides the strength of covalent bond. If greater is the overlapping, stronger is the bond. Okay, so according to orbital overlap concept, the formation of a covalent bond between two atoms results by pairing of electrons present in the valence shell having opposite spins. Okay, so first of all, bond is formed when there are two electrons and those two electrons are having opposite spins, and then they come nearer, and then there is orbital overlapping, and then there is bond formation. Okay, now when we are saying that orbitals of atoms, they overlap, so what does it mean? It means that overlapping may be either positive, negative, or zero. Okay, zero means there is no possibility of bond formation. Negative means that their electron clouds are not of the same side. Not of the same side means that if crest is there of one, then trough will be there of the other. Okay, so it is called negative. Now in case of positive overlap, what is there? There is similar sign or same side of the similar side or same sign of the loops. Okay, in case of positive overlap. So let us define these. orbitals forming bonds should have same sign and orientation in space, then it will be termed as positive overlap. If orbitals forming bond have opposite sign in space, then it is called negative overlap. Okay. Now, if orbital have different directions in space, means one is on x-axis, the loops of one are on x-axis and the other is having the loops on y-axis, then it means they are having different directions. In such case, there is no overlapping possible. So we will say that it is zero overlap. Okay. Now, let us see here diagrammatically positive overlap, negative overlap and zero overlap. Now see, this thing is zero overlap. These two show zero overlap. This thing shows positive overlap and these show negative overlap. Okay. Now first of all, let us discuss positive overlap. Now see, if you see these, this p orbital is overlapping with this p orbital and the same sign loops are approaching each other. Okay. If we take this one p orbital and another s orbital, here it is pz orbital. Z axis is taken as internuclear axis. This is to be remembered. Okay. So we take it as pz. So pz and s, they can also undergo positive overlap. This is px or py. Okay. This way also overlapping is possible. This is for x-axis and this is for y-axis, means this is for one is for px, another is for py. This was for pz and this was for sp. Okay. So what we have seen here, we have seen that when the loops of similar sign overlap with the loops of similar sign, then there is positive overlap. Now in negative overlap, what we will see, when the opposite sign loops, they interact with each other and there is overlapping, then we say it is negative overlap. Okay. Now here you can see, in this case positive overlap, positive loop is here and here negative loop is coming with it for interaction. Here also we can see this is negative loop and this is positive, so it is negative overlap. Here also we can see the loops are in opposite direction, or positive is combining with negative. Here also, if the sign or loops, they are of opposite signs, then it gives rise to negative overlap. And zero overlap means there is no possibility. Here there is no possibility, here there is no possibility. Why there is no possibility of overlap? Because their directions are different. Because of different directions, just like this. Okay. Now let us again discuss types of overlapping and nature of covalent bonds formed on the basis of types of overlapping. This type of overlapping will decide the nature of covalent bond formed. Okay. Now covalent bond may be classified into two types depending upon the type of overlapping: sigma bond and pi bond. Okay. Sigma bond, this type of covalent bond is formed by the end-to-end or head-on overlapping of the bonding orbitals. Okay. So when there is head-on collision or head-on overlapping or end-to-end overlapping between the bonding orbitals, then it is called sigma bond formation, or it is called axial overlap. Okay. And this is possible in three ways. Either two s orbitals can overlap, one s and one p can overlap, one p and another p can overlap. So in three ways we can form sigma bond. Okay. Now let us consider first s overlapping. Now see, now there are two orbitals, this is s orbital, this is s orbital, and both are containing one electron. Those electrons should have opposite spin, and when they will combine, there will be ss overlapping and there will be formation of a bond. Similarly, sp overlapping, this is s orbital, this is p orbital, and this way there is possibility of sp overlapping. Similarly, p orbital and p orbital, they can also undergo head-on collision, and they will result in formation of sigma bond. Okay, so there are three ways in which sigma bond can be formed. Now when we come to pi bond, what is pi bond? Formation of pi bond is in such a way that their axes remain parallel to each other and perpendicular to the internuclear axis. Or what we can say, one exact word for pi bond formation is when the orbitals undergo sidewise overlapping. When the orbitals undergo sidewise overlapping, then there is formation of pi bond. Now see, these are two p orbitals, and here they have gone for sidewise overlapping. Because of this, two electron clouds are formed. Result is like this: one electron cloud above the internuclear axis, one electron cloud below the internuclear axis. So such bond formed is called pi bond. Now to sum up all the points for sigma bond and pi bond, first point is sigma bond is formed by the overlapping of orbitals along their internuclear axis, or we say sigma bond is formed by end-to-end overlapping or head-on collision, and pi bond is formed by lateral overlapping or sidewise overlapping. Okay, sigma bond is possible in SS, SP and PP overlappings, but pi bond is only possible for PP overlapping. Now overlapping is quite large in case of sigma bond, and so sigma bond is very strong, but in case of pi bond, overlapping is less as compared to sigma bond, and so it is a weak bond. Okay, electron cloud in this case is symmetrical about the line joining the two nuclei. It means that if we see from the internuclear axis, there will be equal portions on both the sides. Okay, so that means it is symmetrical about the line joining the two nuclei, but in case of pi bond, such symmetry cannot be seen. Okay, now if we talk about sigma bond, there will be only one electron cloud. Okay, but here, just like now we saw, there were two electron clouds, one above the internuclear axis and one below the internuclear axis. Okay, now last and important is free rotation about a sigma bond is possible. It means that when we rotate our bond formed, then its rotation is possible for sigma bond, because sigma bond is symmetrical for a rotation about internuclear axis, but pi bond is not like that. If we start rotating the pi bond, then what will happen? The bond will break. Okay, so this rotation is not possible in pi bond. Now whatever we have discussed in this session, you need to solve these home assignments. Okay, thank you.